Had a lot of interest in this talk. Personally, this is one that I've been looking forward to as well. Ladies and gentlemen, Melnick and Scott Parker.
All right. Hi, everyone. Again, I'm Dan Melnick. This is my colleague, Scott Parker. We're here to talk about building the Great Wall, API-driven applications. And I'd like to give a special thanks to the previous presenter, Jeff, who actually gave us a great introduction and segue, because a lot of the things he talked about are going to be talked about here. So we have problems. You probably have problems, too. Maybe we have the same problems, and hopefully this talk will give you some ideas on how to deal with them. Part of the problems we deal with are problems of monolithic applications that can get tangled and trying to achieve disparate goals with one big code base that's doing maybe too many things in the same way or with the same code. And you end up with a lot of coupling that you'd rather not have, and so that's what we're trying to move past. So what do we want out of an API-driven application architecture, and why would we move in this direction? Well, we want a system that's adaptable to change. That should be a goal with any good software. Any good software design should be adaptable to change. We want clearer responsibility of the components in that system, so we don't want to get into the situation where things are doing more things than they should be. And also, we want rich client experiences, right? You know, the web is moving in this direction of lots of JavaScript, trying to make the web experience really rich from a user experience perspective. You can compare it to the desktop experience, but really, from my perspective, we want to make the web better than the desktop experience. You know, all the availability of great information through APIs and things like that. We can make the web have a really great user experience through client-side code. So, how we're going to do that is by building Great Wall, and the image is really between the API and the client-side code. That's where the wall goes, and that's why we chose this metaphor for building this style of architecture. So we have multiple clients, and how do we deliver information to these diverse clients? If you've built an application recently, you've probably ran into a situation where you're building for a normal web browser, but you're also building a mobile app. Maybe you're building a mobile touch site. Maybe you're building multiple mobile apps, for Android, iPhone, other types of clients. And then in addition, you might have a public API. Jeff alluded to this earlier, but you don't just build a website anymore. Our lives are a little bit more complicated than that, fortunately or unfortunately. So, richer experiences. We want to deliver awesome experiences to our users, and JavaScript is kind of the state-of-the-art best way to do that right now. We want more desktop-like user experiences, and we really want to entrust JavaScript rather than distrusting it. There's this element of when we write a normal application, a web application, where we render a whole view, send it down to the client, and then maybe you have the rendered HTML DOM, but then you reconstruct it, manipulate it with JavaScript. What if we really delegate a lot of that responsibility to the client and to JavaScript? And people, in the spirit of Ruby, we care about the people who are working on the software. We care about the people who are using the software, and we want the best experiences both for developers and for our users. And by creating this separation of concerns between the server side and client side and really clear responsibilities, we can give our developers better ability to hone in on an area of the system without creating lots of boundary areas where the system overlaps with itself. And there's really clear ownership of components. So really, what's the sane way to architect a system like this? That's the question that we were ultimately trying to answer and work towards. And for us, it's about decoupling the client side and the server side, and also how whoever's consuming this information. We can decouple complexity by creating this API-driven application architecture by isolating the parts of the app that are likely to change. Oftentimes, that is the place where the user's interacting with it, how they're interacting with it, and it's not as often the data necessarily, although that does change, but it's less volatile. And going back again to what Jeff was talking about earlier, when you do this, if you focus on the interfaces and making clean interfaces where these components can communicate with each other, you give yourself the opportunity to have really well isolated components of your system. You can also decouple teams. This may be a problem that you do or do not have, but when you grow a large organization, sometimes having too much shared code and boundary areas of a system can lead to problems, because without clear ownership of an area of the system, it can become a bit of a junk drawer kind of situation where no one really owns this part where these boundaries overlap. And so when you have these sort of leaner slices of your architecture, people can focus on them, they can ramp up on them more quickly without having to take in your entire monolithic application. And in addition, you sort of leads to natural team splits when you have a bigger organization. You also get some additional wins in terms of decoupling performance. You're sending the rendering of the client-side stuff all down to the client. That, of course, has some trade-offs, because now you're targeting multiple platforms, runtimes, things like that. But it is a sort of added win. And in addition, if you're really disciplined about the way you create your API, you can naturally make these sort of silos that can then allow you to scale horizontally more easily, both in terms of application and in database. So the caveat here is that if you don't have these problems, this might not be the best way to approach application architecture. But if you share some of them and you have similar goals, we found this is a good way to approach the problem. So, Scott?
Hey guys, I'm Scott. I also can't sign out of Twitter apparently before giving a presentation. Apologies. So let's say, for the sake of argument, that we're convinced by this, or we're convinced by what Jeff was saying earlier about using Sprout Core and leveraging some of these things. Then let's talk about how we build it. Our job as builders is sort of twofold, right? One, we build the things we're on the hook for building, but we also have to look for these patterns, these ways to build them better next time, to always be better today than we were yesterday. So I want to talk about some of the patterns we've seen in building these kind of applications, so that you sort of know what to expect, because the low-level tutorials, they're out there. You can get started. There's nothing blocking you. Every single person in this room can build this kind of application, even if you know absolutely nothing about JavaScript. So let's talk about the 3 phases of building an API. So we start small, because we're pragmatic people. We use something like Sinatra, or maybe we use a thin Rails application, and our endpoints are very, very simple, very, very straightforward, right? So in this example, because we all use to-do lists as our classic example code, we're just saying, find all the to-dos in our system, return that as a JSON blob. And this is a perfectly wonderful place to start. This is appropriate for a new project. There's no amount of ceremony. It's inappropriate to start building castles in the clouds before you've actually run into problems. But this approach will lead to problems eventually. As you add more and more models, more and more concepts to your business domain, you find yourself writing a lot of repetitive wiring code, right? You'll find yourself doing that same sort of all.2JSON throughout your code base. So that not only is it horrible to be writing the same code over and over, but when it's time to refactor that, you've tied yourself to this approach and you've created more pain than you need to. And in addition to that, there's also the case where you're also writing the same Sinatra code, or same Rails code. We're using Sinatra as an example, but you can do all of this in Rails as well. And so you'll write that pattern of get/model name over and over as a route, right? And especially if you are sticking to kind of CRUD operations, that part of it as well, it's a lot of repetition. So then we move to a different approach. We build abstractions. We detect these patterns, and we build on top of them, right? So again, if you choose Sinatra, it's very easy to build these kinds of abstractions or patterns on top of it. You can do so with Rails as well. I think it may be a little more challenging, but regardless, I think they're both fine approaches. So we automate these things. We say 98% case here is we're doing basic CRUD operations on these time-offs. And that's true of most of our models, so we're going to create helper functions so we don't repeat this. and so that we can make refactorings in one place and have it apply throughout our entire API, right? So these kinds of abstractions are great. We've identified patterns, we've put them into place, rock and roll. We're all awesome, right? So, but this carries with it some problems as well. So as our API grows from here, this sort of approach doesn't really handle different representations of the same model, right? If your code always assumes that I can just pick a model out of my application, call to.json, and pass that down to the client, you're going to run into scenarios where that's not appropriate, right? Where you may want a really good fine-grained look at a to-do item in one case, but in the other, you'll probably just want a primary key and maybe like a human parsable string, and that should really be it. You don't need to know when that to-do item is created or when you finish that, et cetera, et cetera, et cetera. Leave that for an auditing application. And then the same is true as these attributes not simply change between one API endpoint to the other, but in fact, you start to keep more of these things server-side, right? Like you probably want some rich auditing of who's doing what on your system that clients will probably never care about, or most of your clients won't care about. And again, if you're just saying .to.json on some of these things, it becomes very, very hard to make those kinds of distinctions, to say, I want to show these attributes, but not those. And then finally, as you want to scale in various ways, whether you want to support more performance or things like that, this also becomes challenging. A concrete example is, perhaps for some views of these to-do lists, it's okay for them to be 15 minutes or an hour out of date, right? But for other representations of that same model, then it becomes more challenging, and you probably want more real-time availability of that, especially if you've just done a write or something like that that's going to change the state of the application. You need to know right away. Those sort of abstractions and those patterns that we were looking at don't support those kinds of edge cases very well. So we move on to what we kind of call the large scenario. I don't have a great code example here because I think there's a bunch of different ways of solving it, but we're going to talk about those patterns of solving it. So I think just like Jeff was talking about, you can wrap these with decorators or presenters, right? That sort of transform your model based on how it's being consumed. And these presenters can do things like select a subset of the attributes that you're interested in. Or they can do things like say, well, for whatever model you pass to me, I'm going to store this in memcached, and it's going to have a 15-minute expiration date, and it's going to be much better for everybody involved because our database is going to be happy, our users are going to be happy, everything is great. And you can just have this sort of memcached reusable presenter that you can use wherever in your application. You can also go the approach of actually doing like JSON templated views, right? If you're in a Rails application, you can just do .json.erb in a file, and ta-da, you're creating your JSON template, your JSON view. And then that's great. If you're using the built-in Rails functionality, be aware that it's still fairly verbose to do it that way. There's a couple of gems, particularly Robble, that makes it much more wonderful, much more awesome to do this sort of approach and just sort of these declarative JSON views that then you can reuse as appropriate for these different scenarios. And by the way, you'll see a bunch of hyperlinks in there. These slides will be available online if you want to dig into some of this stuff, because I know we're going a little bit fast. So let's talk about the client. Let's talk about how to actually build this. There's a bunch of ways to do this. There's a bunch of great frameworks. We're really going to focus on two of them, Backbone and Sprout Core. ClientSide MVC is different. I'm going to sort of blow through this really quickly. So here's our server-side MVC. Everything goes to the controller. But on the client side, be aware that there's many more ways for data to flow around. Don't bring too much of your server-side mental model into the world of client-side JavaScript if you're doing this for the first time. Just be aware that things are similarly named but are different in use because of these rich abilities to interact. All right, so let's look at two quick examples in Sprout Core. So Sprout Core and Backbone both have this concept of views, right? And these views are a little bit different than what we think of in server views because they make distinctions between the template, the HTML that's going to be rendered, and then also this class that sort of wraps the functionality and behavior of that template that's associated with that template, right? So in this case, we have this dog view that wraps to this dog detail. We actually have to say very little about this. We say that there's this idea of a current dog controller that lives somewhere in our application, and it's going to pull the interesting bits from that current dog. And so this is really nice, because then this current dog controller can worry about things like changing the current dog, or understanding those different system-level changes that require us to change that. And the view can really just say, I don't care what the dog is, you tell me that, and I'll filter these attributes down to it. And so we have an example here of a DogsController as well. And these controllers, again, similar names, but they can do slightly different things. So this example here, we have two things you can do with this DogsController. You can add a corgi, and you can get the whole number of corgis in our system, because really, there are dogs, and then there are corgis. My two Boston Terriers at home will be very sad when they hear this presentation. So the add corgi function creates a new instance of this dog model that we have, right? And then we simply say push object. We add that to our collection. And then this corgis function is actually a little bit more interesting. So we say filter this entire collection based on the property breed, where it's a corgi, and then we want the length of that entire collection. And then we do this really interesting thing. Sorry, I'm stepping out of the light. This property, each.breed, that says this function, this metric, is dependent on the breed property of everything in our collection. So anytime that changes, I change. Anything that's bound to me will also respond to these changes, right? It flows throughout your entire application. So it's very nice, very declarative. So there are pros and cons of this approach, right? The pros is that it's very succinct. It's very wonderful, and Sprout Core comes with these kind of great patterns and abstractions already built for you that you can take advantage of. If you're starting a new application, particularly, I encourage you to take a look at it, because it's wonderful. The cons are very much related to that, though. It is a very opinionated framework. It's very hard to get at some of the raw materials. So if you have a pre-existing application with a bunch of JavaScript code, I would really think hard and long before you dump Sprout Core into that, because I don't think it plays as well with other frameworks as Backbone, which we're going to take a look at. It's also a framework right now that's in a huge state of change. They're working aggressively towards version 2.0, which is awesome and exciting and lean and mean and basically undocumented with large exceptions. So you need to be aware of that. You need to be, if you're not afraid of blazing new territory, then absolutely check it out. But otherwise, you might want to wait a couple of months until there really is a rich set of documentation, which they're building out every day. So let's look at the same things in Backbone and compare and contrast. So again, we've got a dog view, and Backbone has the same idea of we're going to separate the HTML that we're rendering from the class that sort of interprets the behavior and the system changes around it. It's a little bit more verbose, right? There's two key things I want to point out. This view has two methods, render and initialize, that are really interesting. This initialize says, for this model I'm associated to, I need to bind to the change event. Anytime that model changes, I change, which is interesting. We didn't see that before in Sprout Core. One of the patterns of Backbone is that you have, it's very common to get this sort of lower level access to binding, which you can do some really interesting and rich things with, but you have to do really interesting and rich things with it. You have to be aware of that. And similarly, this render function says, anytime it's time for me to render, what I'm going to do is I'm going to pull my HTML, I'm going to slap the updated model into it, and that's going to be my HTML content. So we also have this collection. I label it controller here because it's really the same idea and concept to me. Very, very, very similar. You see that there we explicitly say what model it's related to, but we have this idea of adding a corgi and the count of corgis. And the added corgi is actually a little more succinct, very nice. You have this.add with basically passing in a JSON blob of the new model that you want to add, right? And the corgis function there is also very similar, but you get this nice filter function where you can say, apply this function to everything in my collection, and this function will tell you whether or not I apply, right? Which is a very, very powerful tool. But the two things to be aware of that I sort of point out in this is that you have to be very careful again about binding, right? If something is just pointed at this collection and that's sort of the end of that, then when you add a new corgi, when that count of corgis changes, it's going to have no idea. You need to set that up yourself. You need to be very aware of how you're handling binding. So pros and cons. I think Backbone is a really powerful set of tools. But the con is Backbone is a really powerful set of tools. I don't think it comes with a lot of the opinions and patterns that you'll get with other frameworks. If you have something that's pre-existing, if you already have a pre-existing application with your own patterns and tools, absolutely check this out. But if if you have a newer application, and especially if you don't necessarily have a rich background in JavaScript, be aware that this is a loaded shotgun and you have to be pointing it away from yourself at all times. All right, so we're out of time, so pretend this didn't happen, unfortunately. Sorry, Dan.
No,
but
it's good. So yeah, I'm just going to fly through these in about 10 seconds.
All right.
So you might be used to doing things like rendering conditionally. You can't do that anymore. You can't traverse relationships in your views, which you shouldn't be doing anyways, but you definitely can't because you don't have access to them. You can't do this kind of conditional rendering of Flash things, and in general, you have to rethink the way you're doing validations. This kind of regular JavaScript code that you might be used to writing in jQuery library function is not going to work in the same way. And last but not least, careless deployments. When you're deploying code to a server and you have this kind of rich client-side rendering, you can't do that in the same way. Your API might break your client-side, and you might need to push an update to your client to let them know that. If you've ever used Pivotal Tracker, you might have seen things like this before where they say, hey, you have to refresh your page. You have to consider those things. Corgis. That's all.
Thanks, guys.
Thanks.
First and foremost, EngineYard is a supporter of the Ruby community. We also are a provider of cloud services, and those cloud services are supported. So the idea behind EngineYard is that if you have an open source technology and you need people to actually help you scale it and support it when you deploy, you can come to EngineYard. And so we can provide services that go around and make languages like Ruby and frameworks like Rails or Padrino more effective for use and for actual deployment in production scenarios.